After completing this lesson, you will be able to understand families, understand parameters, configure family types, add a type and instance parameter, and work with subcategories. The objective domains covered are 2.1a, configure family types, 2.1b, understand concepts of family categories and types, and 2.1c, differentiate between various types of families. Families are at the heart of any Revit project and form the building blocks of projects. The families support the actual 3D components such as structural columns, walls and beams, but also support 2D annotations like dimensions, text, tags and title blocks. We can classify all Revit families into 3 different types: system families, loadable families and in-place families. In most cases, system families are typically assemblies of multiple components and layers. In the example of a wall, you may have brickwork, a cavity, blockwork, and finishes, all with different materials. The floor, again, can be comprised of different materials such as concrete, steel decking, or screed. Finally, the stairs are built up of rungs, landings, supports, stringers, and treads. System families are typically created within a project and can be embedded in project templates. System families cannot be loaded into projects but can be transferred from other Revit projects with the use of transfer project standards. Loadable families form the largest area of content that is used in structural projects. Typically, loadable content will be elements such as structural columns, beams, and foundations. In-place families are components that you create that are unique to a project and cannot be used in other projects. In this example, you can see a pile cap with a notch to fit around an existing concrete element. In-place families can be problematic when trying to enforce BIM standards, as these types of elements are typically modelled without too much consideration for using correct categories and parameters. A parametric component can resize and be configured based on a set of rules and parameters that you create. In the example below, a single structural framing family has different parameter values that allow the geometry and associated information to change. Type parameters are used when a series of components needs to be created, such as the W-shaped beams. Here you have one family with numerous types that the user can select and load into a project. Instance parameters are typically used when each element in the project may have a different value. A good example of an instance parameter is the length of a beam. Below you can see the same family type but with different lengths that are assigned to each instance. Go ahead and open up the model 021, Managing Family Categories and Types. The model opens up in a 3D view. Our first task is to create a new family type of a pile cap and pile arrangement. You'll see here that we have an arrangement of 4 piles in a pile cap and the same arrangement over here. We need to create a new family type and increase the diameter of our piles. Let's go ahead and select this pile cap here. In the Properties palette, select Edit Type. Here you'll see that we are currently using a 68" by 68" by 35" deep pile cap. Here we're going to duplicate this family type. So we'll name this one 84 inches by 84 inches by 36 inches deep and click OK. Here we have a nested family within this pile cap. So this is our pile family that we'd like to use. Currently we're using a 16" diameter pile. Let's increase that to 20" diameter. We can then go through and create our foundation thickness. So this is going to be 36 inches. And then the length and width of this will actually be 7 feet in here. And we'll leave the clearance at 1 foot and 4 inches. We can then go ahead and click OK to the Type Properties dialog box. And you can now see that we have a new family type configured. If we go to the Type selector, you'll now notice that we have our 2 original pile cap families and our new pile cap family, 84" by 84" by 36". Next, we investigate subcategories. Before looking at subcategories, this current view here is in a section box. Let's remove the section box. In the Properties palette, uncheck Section Box. We now have the full model displayed. You'll also notice that some floor slabs are hidden in view for the purpose of this exercise. So here you can see that we have some beams on grade down here. These are just structural framing elements. However, if I wanted to be able to control these and differentiate between these grade beams and also the superstructure beams up here, I would need to create a different subcategory. For example, let's take a look at this in Visibility Graphics. Select the View ribbon and then go ahead and select Visibility Graphics. Scroll down to Structural Framing and then expand the subcategories. You'll see here that we have subcategories for items such as girders, joists, bracing and so on, but I don't have a subcategory set up for grade beams. We're now going to create a subcategory for a grade beam. Let's click OK to the Visibility Graphic Overrides box. We'll then go ahead and select one of our ground beams and select Edit Family. We're now in the Family Editor. If we select our geometry, you'll notice in the Properties palette we have a subcategory. Currently this is set to None. We're now going to create a new subcategory and assign this geometry to that subcategory. To do this, select the Manage ribbon and then select Object Styles. Here you'll see the object styles just for the category we're working with, which is structural framing. Notice down the bottom of the dialog box we have the ability of creating a new subcategory. So here we'll name this Grade Beams and click OK. So here we can change the projection line weight of our grade beam and also the cut. So here we're going to match the same as our superstructure. So we're going to say a cut line weight of 4 and a projection line weight of 1. Let's go ahead and select OK. We can then select our geometry, and in the Properties palette you'll note here that currently the subcategory is set to None. We should now be able to select grade beams. So when I use this particular ring beam family and I use it in the project, it will automatically now appear in the grade beam subcategory. So here we can load into project and close. Here I'm not going to save this. The dialog box we can see now is informing us that the family already exists in this project, and in this example we want to overwrite the existing version. So the grade beams have now been overwritten. If we go into Visibility Graphics and we scroll down to Structural Framing again and expand Structural Framing, you'll now notice that we've got a new subcategory that we didn't have previously, grade beams. If I uncheck the visibility and click Apply, you can then see just the grade beams are removed from the project view. This is very useful. This means that I can override the graphics of this grade beam, I can change the coloration and control the visibility of this separately. This can be useful when you want to map the grade beams to a particular IFC property. Next, we investigate nesting families and also how to create some simple formulae. We're going to do this by taking a 2D detail component and utilising that within our pile family. To better understand why we'd want to do this, in the project browser, let's switch to the lift pit plan. You'll notice in the lift pit plan, we can see our pile positions. However, generally in a structural plan, we may want to see a symbolic view for the pile, which is going to be a simple cross representing the center of the pile and then a circle representing the diameter. However, because this is a 3D component, we're actually seeing the physical section through the pile. We can change this. What we're going to do is edit one of these piles. To do this, because it's nested into the pile cap, we will first need to hover and pre-select one of the piles, Press the Tab key and you can see we can then go ahead and select a single pile. Let's select this, and on the context ribbon we can select Edit Family. The pile now opens up in the Family Editor. In the project browser, let's open up the reference level for floor plans. You can see here that we have our 3D model of our pile currently displayed. What we're going to do here is go ahead and insert a 2D detail component from our exercise files. To do this, I can select the Annotate ribbon and then go ahead and select Detail Component. Revit informs us that currently no detail components are loaded. Would you like to load one now? So we'll say yes. Browse to your dataset and then select Pile Plane Symbol _ 2D. Click Open. You'll now notice that we have our detail component placed on our cursor. We'll go ahead and place this down over the top of our pile. Let's review some of the properties of this new symbol. Select the 2D symbol and then select Edit Type in the Properties palette. You'll note here that we have two type parameters set up. We have one for the pile diameter and another one for the line projection. Of course, the pile diameter really wants to match the 3D detail component. To help us understand this better, I'm just going to drag the detail component away from the 3D view. On the Modify ribbon, if I go ahead and select Family Types, I can see the type parameters controlling the pile. So for example here, you can see that I have a diameter for my pile. So in this case, I'm going to reduce this to 12 inches or 1 foot. You'll now notice that the 3D family updates, but the 2D detail doesn't update. We need to link these parameters together. The process is called associating the family parameter. To do this, in the project browser, expand Detail Items folder. Here you can see that we have our Pile Plane Symbol _ 2D. Let's expand that so we can see the family type underneath. Here I can right mouse click over this and choose Type Properties. In this dialog box, you'll notice that the pile diameter can be set. Instead of setting it here, we want to associate this to one of our parameters in our 3D pile family. In this case, of course, it's the pile diameter, this one here. We'd also like to drive the line projection of this symbolic view. So again, I can associate this to a family parameter, but of course here I don't have a suitable parameter set up. So fortunately here I can go ahead and create a new parameter. So here we're going to create a family parameter and it's going to be a type parameter. I'm going to call this one line projection. We're going to group this under our dimensions and we can then go ahead and select OK. Go ahead and select OK again to the Type Properties dialog box. You'll now notice that our 2D detail symbol matches the diameter of our 3D family. Let's return back to Family Types. Notice here now that we have this line projection, which is our new parameter that we just created. To control this, I could set up a very simple formula. Over here, I'm going to make this equal to the diameter of the pile multiplied by 0.75. So really that's going to make that 3/4 of the size of the pile. Let's go ahead and select OK. And you can now see our symbol is configured. All we now need to do is drag this over the pile and lock it in place. We can then go ahead and load this into our project and close. In this case, I'm not going to save changes. And then I'm going to overwrite the existing version. You'll now notice that all my piling is represented with my new 2D detail component. After completing this lesson, you will be able to understand solid and void geometry, create a pile family, work with reference planes, work with family parameters, and work with shared parameters. The objective domains covered are 2.2a, create or delete an instance or type parameter. 2.2b, determine the appropriate parameter discipline, type and grouping. 2.3c, add reference planes, lines and dimensions. 2.3d, create geometry. And 2.3e, associate dimensional parameters. There are 5 different methods to create solid and void geometry within the family editor. These range from a simple extrusion to complex shapes formed from blends and swept blends. The most common types for structural families tend to be extrusions or sweeps. An extrusion simply takes a profile and extrudes it upwards. However, a sweep takes a profile and allows you to sweep it down a complex path. Void geometry is used to cut from solid geometry. This is useful when creating penetrations or recesses into solid geometry. You first create your void geometry and then use the cut command to cut this from the solid. Note that solids can also be joined to form monolithic shapes. So we're currently viewing Revit's home screen. In the home screen, we can create new families. Go ahead and select New. You're then presented with the New Family dialog box. Here we can select a template. The templates have a file extension RFT, and each one of them will generate a specific family. For example, if we want to create a structural foundation, you can see here that we have structural foundation. However, if we want to create a structural column, we have structural column template here. Another option is to use generic models. The benefit with our generic models is we can choose the type of hosting we require. So for example, if I was creating a pile family that needs to be hosted onto the face of something else, I could choose here generic model face-based. In this example, I'm just going to go ahead and use generic model. Let's select Open. We are now in the Revit Family Editor. You can see the ribbon structure across the top is very different from the project environment. So we have a Create ribbon here, and on the Create ribbon we have solid forms. You'll also notice that we have the same forms that create voids. On the Create ribbon, select Family Category and Parameters. In the Family Category and Parameters dialog box, you'll notice that the current category is Generic Model. We're going to change this. This is going to become Structural Foundations. By selecting the family category, this will change the entire behaviour of the family when we use it in the project environment. Also, we'll have different family parameters available in the lower half of the dialog box. Note that these same family parameters are also available in the Properties palette. So here you can see that we have always vertical selected. Well, that will be quite good for a pile family. Generally, sometimes we might want a raking pile, but in this case, our pile is always going to be vertical. The material for model behavior, I'm going to set to concrete. For example, if we were creating a piled wall, we might want these piles to blend together. And I also want the ability to cut with voids when loaded, so I'm going to select that option as well. Let's go ahead and select OK to our Family Category and Parameters dialog box. Next, we create the Parametric Framework. The Parametric Framework is essentially a group of reference planes and reference lines that we add dimensions to. It's very important to get this framework correct before we start adding geometry. The Parametric Framework that we create will also affect how the family operates in the project environment. Generally, most families will have a minimum of 2 reference planes already created in the template. If we go ahead and select the 2 reference planes here, you'll notice in the Properties palette, these 2 reference planes define the origin. We can change this if we want to. We'll also notice here that these reference planes are pinned. We're going to now go ahead and create some additional reference planes. Click the Create ribbon and then select Reference Plane. On the Context ribbon, we have the ability of drawing a line or picking an existing piece of geometry. We'll go ahead here and select a reference plane up the vertical path here. A little tip here is if you hold down the Shift key, the reference plane will be drawn orthogonally. We'll also draw another reference plane horizontally. So again here, I can select a position, hold down my Shift key, and place that horizontal plane. We'll then go ahead and select Modify. Now what I want to do here is create some symmetry around these fixed work planes. To do this, I can simply mirror the reference planes that I've just created. So I'm going to go ahead and select this vertical reference plane here. And on the Modify Context ribbon, I'll go ahead and select Mirror Pick Axes. And I'll repeat that for my horizontal plane. So I now have some symmetry around my reference planes. I want to ensure that this symmetry is persistent when I create the family. To do this, I'm going to add some aligned dimensions and then make them equal. On the Quick Access toolbar, select Aligned Dimension. We'll then select our 3 vertical reference planes and then position the dimensions in between the reference planes, somewhere here. You'll notice that when 3 or more elements are selected, we have the ability of creating an equal constraint. Let's go ahead and make these equal. We'll repeat that for the 3 horizontal planes. Place the dimensions down and make them equal. We now have our parametric framework set up. If I select one of these reference planes on the left-hand side, I can flex the reference plane. To flex the reference plane, I can use the left and right hand cursor keys. And you'll notice as I move the cursor keys backwards and forwards, the planes respond symmetrically. I can do the same for my horizontal planes using the up and down cursor keys. Next, we create some parameters to control our pile family. On the Modify ribbon, select Family Types. In the Family Types dialog box, you'll notice that we've already got length, width, and foundation thickness created. These were created automatically when we selected the category Structural Foundations. However, none of these are useful for our pile family, so we're going to go ahead and create our own parameter. Click New Parameter. We'll begin by creating a parameter for pile diameter. It's important to note here that when you use parameter names, they are case sensitive, so you need to choose a standard and stick to that. Here, this is going to be a type parameter. The discipline is going to be common, and the type of parameter will be a length because it's a dimension. And also here, we want to group the parameters under dimension. The name pile diameter is pretty descriptive, but if it wasn't, I could use Edit Tooltip and I could create a tooltip to give additional help. Let's go ahead and select OK. You can now see that we have pile diameter set up. So I'm initially going to set this to 12 inches. Let's go ahead and select OK. We'll now create some dimensions and assign our new parameter to those dimensions. On the Quick Access toolbar, select the Align Dimension command. We'll place a dimension here and another dimension here. I'll then hold down a Control key and select both of these newly placed dimensions. On the Context ribbon in the Label Dimension panel, you'll note here that we can select that newly created parameter, pile diameter. Note that the reference planes have now driven to that new dimension. I'm now ready to create some geometry. Let's select the Create ribbon. And in this example, we're going to go ahead and use Extrusion. On the Context ribbon, I'm going to select Circle. Let's zoom in to our reference planes. And here I'll select the intersection of the 2 reference planes and sketch out my circle. I need to control the diameter of this circle, so on the same context ribbon, I'm going to select Diameter Dimension. I'll then place a diameter on my circle. Once again, I'll select that dimension that I've just created, and again, assign that pile diameter. Once this is complete, I'll select Finish Edit Mode. and my solid geometry is created. Next, we control the height and embedment of our pile. To do this, switch the view to the front elevation. You'll notice in the front elevation that we have a reference level. This is going to be the level that the pile is placed at. Now, the pile is going to want to project above the reference level, which is going to be the embedment into the pile cap. It wants to have a depth to the toe of the pile. Both of these parameters will need to be set up with reference planes. So let's go ahead and create two new reference planes. Select the Create ribbon and select Reference Plane. We'll sketch a reference plane here to represent a cutoff level and another reference plane down here to control the length of the pile. You'll note here that we can select our extrusion geometry and we have shape handles on top of this geometry. We can drag the shape handle to meet the reference plane and then constrain that using the padlock. We'll do the same at the bottom here and once again constrain it by locking the padlock. You'll now notice that as I drag the reference plane up and down, the pile's length will adapt and change. So we're now ready to place down two new dimensions that we can control the embedment and the overall pile depth. On the Quick Access toolbar, select Aligned Dimension. First, I'm going to dimension the pile length. So I'll dimension from this top reference plane to the bottom reference plane here. Select the dimension, and this time we're going to create a new parameter using this icon here. The difference here is it won't ask us to select the type of parameter. This is predefined because we've started by selecting a dimension. So here we can type in pile length as our parameter name, and we'll accept the rest of the defaults here and click OK. I need to create another dimension. This is going to attach to the top reference plane here, and I also want to attach to the reference plane here. Now you may find that it gets the reference level, so you'll need to use the tab key to make sure that the reference plane is in fact selected. So again, we can now select this dimension here. On the context ribbon, we'll select Create Parameter, and here I'm going to call this one Embedment, and click OK. If we now switch to our 3D view, we can now see our pile in 3 dimensions. We can give it a final check by selecting Family Types, and in our Family Types dialog box, we can now flex the parameters just simply by giving them new values. So here you can see we currently have a pile length of 10 feet and 11 inches. Let's change this to 6 feet and click Apply, and you can see the pile length changes. Again here for the diameter, I might reduce this perhaps to a 10-inch pile, and again hit Apply, and again we can see that change. Okay, so we'll now put this back to some starting defaults here. So we'll have 12 feet there, and we'll have a pile diameter of 1 foot. We'll also set an embedment in here of perhaps 8 inches. Okay, so there's our default pile set up. The last few stages will ensure that we can apply a structural material to this pile and of course save it. So to apply a material, let's select the pile, and you'll notice in the Properties palette we have Material. Now of course I could hard code the material by adding it in here, but what I want to do is associate a family parameter. Because the category is already set to a structural foundation, Revit automatically creates a structural material parameter for us. Let's go ahead and select that. So now you'll note that when we go into our Family Types dialog box, this structural material here will control the pile's material. Finally, we can go ahead and save. So here I'm going to type in situ pile and click Save. After completing this lesson, you will be able to understand type catalogs, export a family type, and create a type catalog. The objective domains covered are 2.3b, export a family to create a type catalog. A type catalog can contain multiple family types in a tabular format. The type catalogue can contain dimensions and other data such as structural properties. A catalogue is much more efficient when there are a large number of family types to create. Also, the user only selects the types required for the project, which can help keep down file size. A type catalogue is simply a text file that shares the same name as your Revit family. Both files have to be placed in the same folder. Assuming the text format is correct, a type catalogue will be displayed when a Revit family is loaded into the project. Go ahead and open up the family 023 type catalog.rfa. The family file will open up in the floor plan. We're now going to export this family as a type catalogue. Before we do this, let's investigate the family types that are created. On the Create ribbon, select Family Types. In the Family Types dialog box, you'll notice here that we have one family type created, 12-inch diameter. This family type is comprised of a number of different parameters. We have some dimensional parameters controlling the pile size, and we also have some custom parameters set up for the structural analysis, in this case the force in the z-axis, as well as some custom parameters for our density data, in this case the pile number. Click OK to the Family Types dialog box. We'll now go ahead and export our catalogue. To do this, select File, Export, Family Types. Ensure that we save this in the same project folder. Don't change the file name as this will by default match the RFA file. Click Save. A text file has now been created and stored in our project folder. Let's go ahead and open up this text file. Once the text file is open, you'll notice it has a very specific format. It's very difficult to understand and edit the type catalogue in Notepad. Instead, we'll import this into Microsoft Excel, which will give us a much better environment to view and create a type catalogue. With Microsoft Excel running, select Open. Click Browse, and ensure in the Open dialog box that we're viewing all files. Go ahead and select the text file 023 typecatalog.txt. Click Open. Excel now displays the Text Import Wizard dialog box. Here we should ensure that we have Delimited selected, as this is a comma delimited file. Select Next. The file is delimited with columns. The default is tabs, so we'll go ahead here and select comma, and you'll now notice that each column is separated. Click Next, and here the formatting is set to General, and finally we can select Finish. The data is now imported into an Excel file. We'll just zoom up on this data and start to expand some of our columns. At the top of each column we have formatting which tells Revit what the data holds. So for example here you can see we have structural material and this is currently set to Other. If I take a look at a column that's holding a dimensional value such as pile length, you'll notice here that we've got pile length, then it's a length, and then the units of feet. The first column here is simply the family type name. So I'm going to go ahead here and make some new family types. So here perhaps we'll have an 18-inch diameter. We'll instance this value here, and we'll pull down the pile number. Here, I'll just keep the pile number the same. For the length, we'll set this to 18 feet. Pile diameter, perhaps we'll now go for 2 feet. The embedment we'll leave at 0.5, and we can keep the description the same, and also the default elevation. So now that we have this line created, we could continue to create new lines of information. When we're ready to save this, it's important that we save it as a comma-separated file. To do this, select File, select Save As. In the file types, ensure that you're selecting CSV, comma delimited. Go ahead and select Save. Browse to the file location in Windows Explorer and ensure that Windows Explorer is set to show file extensions. So you'll see here that we have our original text file and our CSV file. I'm going to delete the original text file and I'm simply going to rename the CSV file to txt. We can then open that up in the Notepad text editor and you'll now notice it has the correct formatting. We can then test our new family in Revit by creating a new project. So here we'll create a new project. And select OK. On the Structure ribbon, select Isolated. On the Context ribbon, select Load Family. And we'll now select our RFA file 023 Type Catalog. Go ahead and select Open. You'll now be presented with a Specify Types dialog box. This is our catalog file. Here we can select the family we want to load in and go ahead and select OK. The family type is then created and we can place it. After completing this lesson, you'll be able to understand called out views, create a called out view of the core walls, and dimension the core walls. The objective domains covered are 3.1a, use dimensions, and 4.1e, create and manage elevation and called out views. A called out creates a detail at a larger scale. A called out can be rectangular or polygonal to suit your geometry. A callout typically will then contain additional 2D detailing to provide more information about construction details. Go ahead and open up the model 024, creating and managing callout views. The model opens in a 00 ground floor plan. Our first task is to create a callout of our core area. Let's go ahead and zoom into the core area. To create the callout view, select the View ribbon, and here you will find Callout. Note that there are two methods to create a callout. For simple geometry, as we have here, we can use a simple rectangular callout, but we also have the ability to sketch a polygonal shape for more complex geometry. In this example here, we'll go ahead and select Rectangle. We can then construct a rectangle around our geometry. Once we've constructed this rectangle, we can select the called out fence and utilise the grips here to move the clip planes or reposition the call out head. Once this is done, we can then go ahead and open up the called out view. You'll notice by default that it's named 00 ground floor -called out 1. We'll begin by changing the scale factor. On the View Control toolbar, you can see the current scale is 1/8 of an inch is equal to 1 foot. We'll go ahead and change this to 1/4 of an inch equals 1 foot. We can then rename the view. So here we'll call this one Core Details. We're now ready to detail our core walls. Let's begin by adding some aligned dimensions to detail the core walls. On the Annotate ribbon, select Aligned Dimension. When adding dimensions, by default, you can select each face of a wall and then place a dimension down. To make our dimensioning more efficient, rather than picking individual references, we can pick entire walls. We can then configure the options. In here, I want to also detail openings, but I want to detail the widths of the openings rather than from the center line of the opening. I also want to be able to obtain intersecting walls, but in this case, I don't want to get intersecting grids. So we can go ahead and select OK. And here now, we can pick an entire wall and then place our dimensions down. We'll repeat that on the right-hand side over here. When using this method to pick walls, you'll note that sometimes we get dimensions that we don't actually require. For example, here I've got a dimension of 0 inches. We can remove these dimensions by selecting the string of dimensions and then right mouse clicking over the witness line. So here we can delete the witness line. And we can then repeat that in this area here. So we can locate the witness line, right mouse, and delete the witness line. To make the dimensions a little more readable, we can drag the text. So I'm going to select this string of dimensions here, and then I can use the grip here to drag the text to a better location. To further tidy up the dimensions, you'll notice here that we have witness lines which are projecting down to the elements. This means sometimes that the witness lines will travel through the object itself. Of course, I can manually edit these just by dragging these witness lines, but there's quite a few to do. So what I'm going to do now is create a new dimension style to suppress these witness lines. To do this, I can select the string of dimensions, and in the properties palette here, you can see currently I'm using this linear dimension style arrow 3/32 Arial. Let's select edit type. I'm going to duplicate this dimension style, and after the text Arial, I'm going to type in here no witness lines. If we have a look down through some of the properties here, you can see that we have witness line control. Currently, this is set to gap to element. I'm going to change this to fixed to dimension line, and you can then see the fixed witness length line will be 3/32 of an inch. Let's go ahead and select OK. You can now see that all of our dimensions have changed and the witness lines are now a fixed length. To apply that to other dimensions, for example over here, I can select the string of dimensions, go to the properties palette, and in the type selector, you'll now notice that we have different styles. So here I can use my no witness line style, and that quickly edits all of the witness lines to that fixed length. After completing this lesson, you'll be able to understand 2D detailing, load a detail component, create a repeating detail, add repeating details, and create detail groups. The objective domains covered are 1.1g, understand the functions and limitations of model and detail groups, 3.2a, load and create a detail component family, 3.2b, add a detail component, and 3.2c, define a repeating detail. When creating a Revit model, the level of detail needs to be carefully considered. For example, you may choose not to model small items such as bolts, fixings, and other elements such as grout and membranes. If these items are modelled in a large project, the file size and model performance may suffer. Instead, you can represent items such as these with 2D details. The image on the left shows an original section from the 3D model. The image on the right-hand side is the same view, but has been 2D detailed to convey full construction details. Repeating details are detail components that are configured to pattern along a path. For example, a roof tile can be repeated along the slope of a roof, or a shear stud can be patterned along a composite floor deck. Revit contains a library of repeating details. However, it's prudent to know how to create your own repeating details. Go ahead and open up the model 025, creating and using detail components. The model opens up in the section Composite Slab Edge Detail. In this view, you can see that we have some 3D model elements, such as structural framing, floors, and columns. Other elements, such as this casting channel and bolt detail, are detailed with 2D detail components and filled regions and masking regions. These elements would only appear in this view. Let's go ahead and load a 2D detail component and then place that down on the view. To do this, select the Annotate ribbon, select the Component tool, and then select Detail Component. In the Properties palette in the Type selector, you can see the detail components that are loaded in our current project. To complete our detail, we need to load a shear stud. On the context ribbon, you'll note we can load family. We can now navigate through the folders to find a specific family we're interested in. So this is Division 5 Metals. And here we're going to open up the first folder and then Metal Fastenings. And in the list here, we'll find we have Shear Connectors side. Let's go ahead and open this. In the Properties palette, we can now navigate to our shear connector, and here we have different sizes available. In this example, we're going to select the 1/2 inch shear connector. And we can then go ahead and place that down on the view. To improve the process, we can make use of a repeating detail. We may require a shear stud at every second position on our metal deck. To achieve this, we can use a repeating detail. On the Annotate ribbon, you'll note here under Detail Component, we have Repeating Detail Component. This is simply a 2D detail component that is designed to repeat or instance. So you'll notice by default here, I have a concrete masonry unit that I can produce just by pointing the mouse and clicking. In this example here, we're required to create a new repeating detail for our shear stud. So here, I'm going to click Edit Type, and we'll duplicate this style. So here, we'll have a shear stud with a 16-inch spacing. We can then go ahead and choose our shear stud. So we want the 1/2 inch shear stud. We're utilising a fixed distance in here, but of course we could use maximum spacing or we could have a fixed number. And then we have to declare our spacing, which we've said is going to be 16 inches. And then generally here, we'll need to rotate our detail component. In this case, it will be 90 degrees clockwise. Let's go ahead and select OK. We can now test our repeating detail out in space over here, and we can see that it appears to be working correctly. So now we can go ahead and place our repeating detail. And you can now see we've placed a shear stud every second position. Next, we place 2 3/4 inch bolts on this connection here. On the Annotate ribbon, select the component pull down and then select Detail Component. In the Properties palette in the Type selector, we can search. So here, I'm going to do a search for 3/4 inch. And you can see in this example that it's found our 3/4 inch bolt, but also found the shear connector 3/4 inch. Let's select the 3/4 inch bolt. Note that you can press the spacebar to orientate and rotate the detail component. So we'll now place our first bolt down. We need to change the length of the bolt, so we can select the detail component and we can use the shape handle here to change the length of the bolt. Also, we need to ensure that it's set out in the correct position from the top of the beam. So in this case here, we're going to set this to 2.5 inches. We can now mirror the bolt around the central axes of our beam. Let's go ahead and select the bolt. And on the context ribbon, we can select Mirror Pick Axes. We can then select the central axes of our beam, and the bolt is mirrored. You'll notice that this particular detail component is showing us the shank of the bolt. What I might want to do is have the option of removing the visibility of the shank. For example, if I select the bolt, you'll notice in the instance properties, the only thing I can change here is the length. So what we're going to do now is edit this detail component and add in some functionality to control the visibility of the shank. On the context ribbon, select Edit Family. The detail component opens up in the Family Editor. For clarity, the Annotations category has been removed from this particular detail component family. To see this, let's select the View ribbon and select Visibility Graphics. In the Visibility Graphic Override dialog, let's select Annotation Categories and select Show Annotation Categories in this view. You'll now notice that the reference planes, annotations and dimensions are now displayed. Now here we have two detail lines representing the bolt shank. I'm going to hold the Control key down and select both of these detail lines. Note in the Properties palette we have the option of removing the visibility of these items. If I did this, this would permanently remove these items from the family. I want to control this with a parameter. So just to the right of this, I have Associate Family Parameter. Let's go ahead and select this. Currently, there are no parameters to associate this to. So what I'm going to do here is create a new parameter. Here, we'll call this one Bolt Shank Visibility. And here, we're going to make this an instance parameter. You'll notice that the type of parameter is a yes/no. That's because we've selected the visibility option that can only be yes or a no. And we'll group parameters under dimensions. Let's go ahead and select OK. We can then select OK again to the Associate Family Parameter dialog box. Now you may notice in the project environment, when we use this particular detail component, the shank of the bolt masks out other elements underneath it. To do that, it must have a masking region underneath. Let's check this. If we move over the shank and then press the Tab key, you'll notice here that we can cycle our selection, and in fact here you'll see that we have a masking region. Let's go ahead and select the masking region, and once again in the Properties palette, we'll associate the family parameter. Here we can click the same parameter, Bolt Shank Visibility, and then select OK. It's now time to go ahead and test this. Again, to declutter the display here, we'll now remove our annotation categories again. So I'm just going to right mouse here and repeat the visibility graphics. Select Annotation Categories and then remove Show Annotation Categories in this view. We can test the operation of a family by using this tool on the View Control toolbar, Preview Visibility. Currently it's set to off. Let's set it to on. On the Modify ribbon, select Family Types. In the dialog box, you'll now note that we have a new control for bolt shank visibility. Let's uncheck this and then select Apply. You should now notice that the shank disappears. If we recheck the option and then select Apply again, the shank reappears. We'll go ahead and switch the preview visibility off. Of course, I could do Save As, but in this case, I'm just going to go ahead and load this into Project and close. So here, I'll say No to save changes. And of course, in a project environment, I want to overwrite the existing bolt. So that's now complete. We can go ahead and select the two bolts. And in the Properties palette, I can now select Bolt Shank Visibility and remove that. And of course, you'll now see that those lines of masking region are suppressed for these two bolts that I've selected. Because this is an instance parameter, each bolt will have the option of showing or removing the shank. So in this example, of course, I do want to see the shank. I might want to save our detail components and line work so I can apply it to another slab edge. To do this, I would create a detail group. I can window select everything in the view, and then on the context ribbon, I'll go ahead and select Filter. I'll check None, and here I'm going to select Detailed Items and also my line work. Let's select OK. On the context ribbon, you'll note that we can now create a group. For the group name, we'll call this one Slab Edge Detail, and then select OK. So the detail has now been saved. In the project browser, you'll note that we have a folder for groups, and here we have our detail group. If I'd like to use this in another view, I can simply drag and drop it and place it down. Very much like other groups, if I want to edit it or change it, I can select the group, and on the context ribbon, I could click Edit Group. Here, we could add new components or items, or remove components and items. Once we've done that, when we select Finish, it will update all the other groups in the project. It may be the case that we have a slightly different detail on a slab edge. What we can then do is select the group, and we can ungroup. And that essentially explodes the group back down into detail items, line work, and detail components. And of course, then we can make changes without affecting the other groups. Okay, there's our composite slab edge detail complete. After completing this lesson, you'll be able to understand view templates, understand view range, duplicate structural plans, create a view template, and also work with view range. The objective domains covered are 4.1b, Set View Properties, 4.1c, Apply Visibility Graphic Overrides, 4.1d, Apply and Edit View Templates, and 4.1h, Use Duplicate Views. When creating drawing views, it's important to maintain graphical consistency between different view types. For example, high-rise buildings will need a general arrangement plan for each story, and these should be consistent in their graphical appearance. Other examples could be reinforcement drawings. You can hide the hatching on a section and set rebar to show a single lines with a predefined line thickness. These situations are where view templates become very useful. When creating plan views, the view range controls where the plan is cut, and also how far you look down. The view range can be set for each plan. Plan regions can override this view range for certain areas on a plan. Go ahead and open up the model 026 Duplicating Views Part 1. The model opens up in a 3D view. You'll notice in this particular model that we have a service tunnel running underneath our building structure. Let's take a look at this service tunnel in a plan view. In the project browser, go ahead and open up -02 lift pit. You'll notice that the service tunnel doesn't appear in this view, and this is the deepest view we have in our building structure. The reason for this is it's outside of our view range. In the Properties palette, go ahead and edit View Range. In the View Range dialog box, you'll note that we have something called a primary range, which is comprised of a top plane, a cut plane, and a bottom plane. Then we have an additional plane called View Depth. By default, the bottom range and the view depth will be set the same. Some general rules with the primary range is that the top range cannot be lower than the cut plane. You can see here that the cut plane is running 1 foot above our associated level, which in this case is the lift pit. The top plane is currently running at 2 feet above the lift pit plane. If I change this to 6 inches and then click Apply, you'll see that we have an error. The top clip plane is set below the cut plane. So the top plane here has to be the same or greater than the cut plane. The same is true for the bottom range. The bottom range cannot be deeper than the view depth. You can see here the bottom range is set to -6 feet. If I set this to -8 feet and then click Apply, again I'll get an error. And now you can see the view depth plane is set above the bottom clip plane. Okay, so if I need to see my service tunnel here, what I could do is I could set the bottom range to unlimited and also make sure that the view depth is set to unlimited. If I click Apply, you'll now notice that we can see the service tunnel. So what's the difference between the bottom plane and the view depth plane? Here, I'm going to change my bottom plane to, again, associated level -02 lift pit. If I now click apply, you'll now see that the view depth is displaying the tunnel slightly different. This time we have a red dotted outline for the tunnel. So let's investigate this in a little bit more detail. Go ahead and select OK to the View Range dialog box. Select the Manage ribbon and then select Additional Settings. Here we're going to select Line Styles. You'll note here that we have a category called Beyond, and you'll notice here we've set the projection pen weight to 1. We're using a red pen and we've got 1/8 of an inch dashed line. If I change this to green and click OK and OK again, you'll now see that our tunnel updates to green. Let's now set up the view range for the ground floor plan. In the project browser, open 00 ground floor. You'll notice on this ground floor plan that in fact we're seeing the top of foundation. Let's again set our view range. In the Properties palette, select Edit View Range. The reason we're seeing the foundations is you'll notice that the bottom plane and also the view depth plane is set below the ground floor. So we'll just go ahead and set both of these to 0 and then click Apply. And of course, I now just see the ground floor. Go ahead and select OK. Next, we create and then apply view templates. Currently, our ground floor plan has a scale set 1/8 of an inch equals 1 foot. You'll also notice here that the visual style is set to wireframe. I'm going to go ahead and select Hidden Line. We also have a span direction symbol showing on the plan. I want to remove this, so I'm going to select the span direction symbol, right mouse click, and we'll hide in view category. So I may want to save this configuration in a view template so I can apply it to all of my other floor plans. To do this, select the View ribbon and select View Templates. Then select Create Template from Current View. We can give this template a name, so I'm going to type in here Floor Plan GA and click OK. We can now review the view template settings. So on the right hand side, you can see that we're including things like the view scale, the display model, the detail level, and so on. Now I do want to include all of these properties, but if I did want to remove, for example, the scale, I could simply uncheck that. Okay, let's go ahead and select OK to our view templates dialog. Now before I set the view template on the other views, let's just go ahead and open up some of these. So if we open up perhaps the first floor plan, we can see here that the current scale is 1 inch equals 10 foot. If we go to the second floor plan, here we've got 1/2 an inch equals 1 foot. And so on. So we have lots of different configurations, different items displaying, and so on. So here I'm going to go ahead now and select all of my floor plans, right mouse click, and apply a view template. Here we can select our floor plan GA and go ahead and pick OK. So now we have consistency with all of our floor plans. Okay, let's now switch to the 05 fifth floor plan. When we zoom in to the roof slab, you'll notice here that the roof slab is being cut at an unusual angle. Of course, the roof slab is actually sloping. If I select the slab here, you'll notice in the Properties palette that we have a slope angle of 6 degrees, and hence why it's cutting. Now, of course, I could change the overall view range, but here's where we can actually utilize something called a plan region. On the View ribbon, select Plan Views. Go ahead and select Plan Region. On the Context ribbon, select Rectangle. And we'll sketch a rectangle around our core. You'll notice in the Properties palette that we can edit the view range just for everything inside our boundary. Let's go ahead and select Edit. Now here, I'm just going to change the cut plane to match the top plane. So I've set that to 6 feet. We'll click Apply. and then when we select Finish Edit Mode, you can now see the plan looks a lot better. You'll also note that the plan region is displayed here as a green dotted line. You can select this and use the shape handles to change the position of this plan region. Okay, let's return to our top of foundation plan. On the top of foundation plan, we're going to be required to put down some spot levels and also some spot coordinates to show positions of each of the foundations. This is going to mean that I need to select a scale where I can clearly read all of these annotations. The problem with that, of course, is when we try to get this overall plan onto a sheet, it may be very difficult to fit it onto a standard sheet size. So another option we've got is to duplicate the views as dependents. That will allow us to then go ahead and split the foundation perhaps into an east and a west section. In the project browser, let's select Top of Foundation View, right mouse click, and you'll note here that we can duplicate the views. In this example here, we're going to duplicate as a dependent. So you can now see we have a dependent view. Let's go ahead and rename this, and we'll call this one West. If we zoom out, we'll notice that we can see the crop region. Let's select the crop region, and we can use this now to crop the view. Okay, so the west view is cropped. Let's now duplicate again as a dependent view to create the east side of our foundation plan. So again, we'll duplicate view, duplicate as dependent. We'll rename, and this will now become east. And again here, we can use the crop region and crop the view. Okay, the view is now cropped. If we go back to our top of foundation plan, we can now see the overall plan. And in fact here, we can start to detail it in this view. And then these dependent views are of course dependent on that plan. And these are the views that I can then position onto a drawing sheet. After completing this lesson, you'll be able to understand match lines, understand legend views, and create a legend view. The objective domains covered are 3.1c, create legend views, 3.1e, use a match line, and 4.1h, use duplicate views. When a view is split, a match line indicates the location where the split takes place and allows the user to match the views when placed on sheets. A match line is used in conjunction with dependent views. A view reference can then be added either side of the match line to indicate which sheet the detail is placed onto. Legend views are used to produce a schedule of elements shown in drawings. A typical legend may contain the following items: annotation legend, model symbol legend, line style legend, materials legend, and phasing. So typically the annotation legend will display things such as section heads, elevation markers, symbols, and many other annotation elements. Model symbol legends can be built up out of things like walls, beams, or perhaps even things like pile caps. Line style legends will show the line types and styles that have been used in the drawing. The materials legend will simply show swatches and samples of materials in section. And finally, the phasing will use a colour representation of construction phases to match your phasing graphical overrides. Go ahead and open up the model 027 Duplicating Views Part 2. The model opens up in the top of Foundation Structural Plan. You'll notice that this particular plan has two dependent views, the Eastern Foundation Plan and the Western Foundation Plan. Our first task is to create a match line to show where the split is on the plan. To do this, select the View ribbon and then select Match Line. In this example here, I'm simply going to draw the match line down grid 5. And we can then go ahead there and click Finish Edit Mode. So the match line is now created. To make it a little bit more prominent on the view, I'm going to change the colour and thicken up the line type. To do this, I'm going to utilise Visibility Graphic Overrides. Again, on the View ribbon, select Visibility Graphics. In the Visibility Graphic Overrides dialog box, let's select Annotation Categories. And in the Annotation Categories, let's search for Match Line. As well as being able to control the visibility of match lines, we can override the graphical properties of these elements. Let's select Override. In the Line Graphics dialog, we can change the colour. Let's make this red. And we can change the line weight. I'm going to set the line weight to pen 10. I'll click OK and OK again. And we can now see our match line is much clearer on the plan. In the project browser, you'll notice that we have 3 drawing sheets created. Here we have S007, which is carrying the East Foundation GA, and S008 displaying the West Foundation GA. Let's go ahead and open up S007. So you'll see here that the Eastern Foundation plan's been added to the drawing sheet. And again, if we open up the West, you can see the Western one's been added to this sheet. Let's return back to our foundation plan. And now we're going to go ahead and add some view references to the match line. On the View ribbon, select View Reference. On the Context ribbon, you'll notice we've got a Targets view. So here, I'm going to begin by making sure I place down the structural plane East. It's automatically carrying the view number and the drawing number. So I'll go ahead and place that here. I'll now repeat the command and set the structural plane to West, and now I can go ahead and place the West structural plane down. You'll notice that the detail number on the Western plane is W, so what I'm going to do here is now edit the detail number for the Eastern plane. To do this, we can just simply select the Eastern plane, and in the Properties palette you'll see the detail number is currently set to number 1. Here we'll type in E. And of course, our view reference automatically updates. Next, we create a legend for some walls. Before we create the legend, let's open up the 00 ground floor plane. On the ground floor plane, we'll see a core area over here, and you'll notice at the minute that all the walls appear to look the same. If I change the detail level to a coarse level of detail, you can now see that we have different colours being displayed. The colours are representing the construction process of these walls. For example, if I select one of these green walls here, and I select Edit Type, you'll notice here that the coarse scale fill pattern is set to solid, and the coarse scale fill colour is set to green. Alternatively, if I select this blockwork wall here, and once again click Edit Type, you can see again here the coarse scale fill pattern is set to solid and the coarse scale fill colour is set to blue. So our task is to now create a legend view that we can then drop onto a drawing sheet. In the project browser, let's open up the sheet S001 Ground Floor GA. And again, you can see here that we're showing the same colours on this drawing here. To create a legend view, on the View ribbon, select Legend. Here we can name the legend view, so we'll call this one Wall Types. And we'll leave the scale 1/4 inch equals 1 foot and select OK. To place the legend components, I will first select the Annotate ribbon. And then I can go to the Detail Component drop-down and select Legend Component. On the Options bar, I can select the family that I'd like to start displaying, as well as the view, whether it's a sectional view or in fact a plan view, and the sample length of my wall. I'm quite happy to have this at 3 foot. So I'll begin by placing my first legend component down. Now you'll notice straight away that the jump form wall was green on the sheet, but in this particular view it's grey. That's because our detail level must match what we've placed on the sheet, in this case coarse. Okay, so let's continue to place some more legend components down. So we'll go back to legend component, and here we'll select our RC wall 10 inch, our RC wall 12 inch, and also our blockwork wall with render. Now to annotate these, we simply use text. So I'm going to select text. We'll bring out a text window, and here we can type in RC jump formed wall. And now once we've got one in place, we can just simply hold the Control key down to copy and then edit. Okay, so we can now edit the text. So this one will be blockwork. And this one here was a RC 10 inch wall and RC 12 inch wall. Okay, so once we have our legend created, we can then open up the drawing view. So that's our ground floor plan. And we can simply drag and drop the view from the project browser onto the drawing. And there's our legend view on the drawing. You'll note that we have a viewport title shown. We'll select the legend and then say no title. And there's our drawing and legend complete. After completing this lesson, you will be able to understand site plans, set view properties, and override visibility graphics. The objective domains covered are 4.1b, view properties, and 4.1c, visibility graphic overrides. A site plan can be used to show the true orientation of a structure relative to true north. When working with projects, generally you will work in the building orientated to the project north. The shared coordinates will be acquired from the Revit site file that contains the topography, the survey data, and other relevant civil structures. Go ahead and open up the model 028, creating a site plan. The model opens up in the structural plan 00 ground floor. Our first task to create a site plan is to duplicate the ground floor plan. In the project browser, right mouse click over ground floor, and then select Duplicate View, Duplicate. You'll now notice that we have a copy of the ground floor plan. Let's go ahead and rename this copy. So once again, right mouse click over 00 ground floor copy 1 and select Rename. Here we'll name this 00-site plan. Okay, so our view is now copied. To ensure that we capture all of the vertical extents of the building structure, we will edit the view range to look all the way up and all the way down and not cut the plan. To do this, in the Properties palette, select Edit View Range. In the View Range dialog box, we'll set the primary range, top, to unlimited. We'll set our cut plane to something higher than the building structure. So in this case, if we use perhaps 10,000 feet, that will be perfect. And for the bottom range, again, we'll set this unlimited. Now, of course, here we'll have to match this with our view depth, and that would also be set to unlimited. Go ahead and select OK. So you can now see that we're seeing the full extents of the building, both up and down. Next, we use visibility graphics to remove the unnecessary structured elements that are displaying in our current plan. To do this, select the View ribbon and then select Visibility Graphics. In the Visibility Graphic dialog box, note that Model Categories is the active tab. Here, we'll select all of the elements in this active tab. We'll uncheck all of the elements, and here we just want to display floors. Now, if we expand the subcategories of floors, you'll notice also we're showing things such as hidden lines, interior edges, slab edges, and so on. All I really want here is the boundary of the floor. So we can remove all of the subcategories here. Now, also, we only want to see grids from the Annotation Categories tab. So let's select Annotation Categories. Once again here, we can select all of the categories in this tab, uncheck all of the categories, locate grids, and ensure that just the grids are displaying. We can then go ahead and select OK, and you can see here we have a much cleaner structural plan. Next, we orientate the site plan to record our true north position. By default, all of the planes in Revit are set to Project North for the orientation. In the Properties palette here, you'll notice we have Orientation and we also have Project North set. However, the exception is for a site plan. So I'm now going to set the orientation from Project North to True North. And you'll now see the plan rotates. Also notice, because of our crop region, we have some elements that are now out of the view. On the View Control toolbar, select Show Crop Region, and we'll use the crop boundary control grips here to set the crop boundary so we can see the full view. Once we've done this, we can then hide the crop region. We now need to place down a symbol to document true north position. To do this, select the Annotates ribbon, and here we're going to go ahead and use a symbol. However, you may remember in a previous step we used visibility graphics to remove all of the annotation categories other than grids. What's going to now happen is this: when I select symbol, you'll see in the Properties palette in the Type selector we have our True North symbol, but note I can't see this on the cursor. If I go ahead and place this down, we'd also get a warning. So the warning is stating that none of the elements that we've just created are visible in this view. A quick way of finding this element and then selecting it visible is to use Reveal Hidden Elements. So on the View Control toolbar, select Reveal Hidden Elements. You'll now notice you can see our north arrow. Select the north arrow. On the ribbon, select Unhide Category. And now we can simply toggle the Reveal Hidden Elements mode off. And there's our north arrow displayed. Finally, we'll place down some spot coordinates to document the corners of our building slab. Once again, on the Annotate ribbon, you'll note we have spot coordinate. We can then zoom up to the corner of a building slab and we can place down a relevant coordinate. Now again here, you'll notice that this is switched off, so we can go back to Reveal Hidden Elements, select our spot coordinate, Unhide Category, toggle Reveal Hidden Elements mode. Then we can go ahead and continue to place down some spot coordinates. Okay, so there's your site plan created. After completing this lesson, you'll be able to understand schedules, work with schedules, create a structural framing schedule, and calculate approximate steel tonnage. The objective domains covered are 4.2a, Develop and Customize Schedules, and 4.2b, Manipulate Schedule Data. Schedules can be used to report on almost all elements that are created within Revit with a simple tabular format. The schedule could report on material quantities used, or perhaps be used to understand steel section usage within a project. You can format and group and sort the schedule to present data to your exact requirements. Go ahead and open up the model 029 Developing Schedules. The model opens up in a 3D view. We'll begin by reviewing a schedule that's already been created. This particular schedule we're going to look at here is going to be the steel column schedule. In the project browser, under Schedules Quantities, go ahead and open up Steel Column Schedule. We can now review this schedule. So you'll notice here that we just simply have two rows, which means we have two types of column that are steel in the project. So we have WC1 and WC2. A very useful property with schedules is we can actually understand where we've used these in the project simply by selecting the items. So for example, if I select WC1, you'll note here I have highlight in model. If I select this, you can now see here that Revit's highlighted those columns in this particular view. If I wanted to isolate those, of course, I could come down to the View Control toolbar, select Isolate Element, and I can understand now exactly where those columns have been used. Let's go ahead here and go back to Temporary Hide Isolate, and we'll reset the Temporary Isolate. Okay, so there's a column schedule that's already been created. Now, in this particular case, we're using the structural column schedule here to mark the items and then later put this onto a drawing sheet. We're going to repeat this for structural steel framing. So we'll close down our steel column schedule and we'll now create a new schedule to represent our steel framing. To do this, select the View ribbon and then select the Schedules drop-down. On the Schedules drop-down, select Schedules Quantities. You'll notice in the filter list, we're just showing structural categories. And then from the structural categories, we'll select Structural Framing. Of course, here we have the opportunity of changing the framing schedule name and also the phase that we're scheduling. This entire project is all new construction, so we can leave the phase as is. Let's go ahead and select OK. We're now in the Schedule Properties dialog box. This dialog box is primarily made up of 5 tabs: Fields, Filter, Sorting and Grouping, Formatting and Appearance. In the Fields tab, we have the available fields that we can schedule, and on the right hand side we have the scheduled fields. The idea here is we'll move our required fields from the left hand side to the right hand side. So let's begin by taking across something called the type mark. This will be something that the user adds based on the type of beam. We'll then of course need to know the full name of the beam. That's going to be type. We'll then add the cut length through. So we'll go ahead and find cut length and once again double click. We also want the count, so we can add that through. And what we might want to do is filter the framing schedule based on the material that we're using. To do this, you'll notice at the top here we have select available fields from. Now currently we've been bringing all of our fields from the structural framing category, but of course here we can use other categories if we want to. Specifically here we have structural material. Now if we take a look at our materials in here, you can see that we've got all sorts of different things we could utilise to actually filter and understand our material. Here I'm going to go ahead and use the subclass of material. So we're now ready to look at a raw list of this data. If we click OK, you can now see that we have a tabular schedule showing all of our various different columns. We have a separate line item for every structural framing element in the project. What I'd like to do first is filter my schedule. If we have a look at the final column on the right hand side under E, you'll note here that we have some properties showing steel and other properties showing standard. The standard ones are the concrete elements and the steel ones are the ones I want to retain. To remove these from the list, I'm going to go ahead and use filter. If you take a look at the properties palette on the right hand side here, you'll see that we have an array of edit buttons which will take me into the relevant tab in the Schedules dialog box. So here I'm going to select Edit for Filter. In the Schedule Properties, you'll note here that we can filter by the material subclass, and I want the material subclass to be equal to steel. If I click OK, you'll now notice that our schedule's rolled up and it's only showing me the steel elements. Next, we might want to understand the smallest element in our framing schedule as opposed to the longest or largest length of element in our schedule. To do this, we could sort the schedule by the cut length. Again, in the Properties palette, you'll note here we can edit the sorting grouping. In the Sorting Grouping dialog box, perhaps here, I could sort by cut length. Now I can see the smallest element at the top here. And if I scroll down to the bottom of the schedule, here is the longest element, 92 feet. This can be very useful, particularly if we need to splice the steel to ease construction. Okay, so we're now going to turn this schedule into something we could use on a drawing. Currently, we're itemizing every single element in the project. What I want to do is now sort it by its section type, remove the cut length, and then itemize every instance off. So instead of having a single line item for every single item in the project, I'll see a count. To do this, we can go back to sorting and grouping and we can click edit. And the first thing I'm going to do here is remove itemize every instance. We're going to sort by type. And I did say here that we no longer require the cut length, so we can go to the Fields tab and we can now remove cut length from the scheduled fields. And of course that adds it back to the available fields. We also might have the opportunity here of being able to move these items up and down the list. So I'm going to move the count right to the top of the list. We've then got type mark and type. Now you'll also notice that in our schedule visible, we have still. Now I only really want to use this to assist me to filter the schedule. So what I can do here is go to the Formatting tab, select Structural Material, and here I can make this a hidden field. That means that the filter will still operate on this field, but it will not be visible in the schedule. And here's our schedule. Now you'll notice here at the minute everything is rolled up and we now have a count of every item in the schedule. Again, if I wanted to use this to understand where I've used each type of steel section, I can do that. For example, here I can see that I've used 25 of these items here. So I can select the line item, select highlighting model, and here I can see those elements. And once again, if I wanted to understand that slightly better, I could isolate those elements in the view. And you can see here, these are my stub beams. Okay, let's go ahead and reset that temporary hide isolate and switch back to our structural framing schedule. The last step here is to assign each of our framing items a mark. So you can see here we have type mark. So I'm going to begin with my W sections, and here I'm going to call this one W1. This dialog box here is just telling me that I'm changing multiple elements. That's absolutely fine. Then we have W2. And then here I'll just name the rest of them B1, B2, and so on. And this one here will be B5. And finally, this one here is our flat bracing, so I'll call this one BR1. All of my structural framing elements are now marked. What I now might want to do is sort the schedule based on its type mark rather than the type. Now that I've given each type a mark, I can go back into my schedule, select Edit for sorting and grouping, and now we'll sort by the type mark, and then select OK. Finally, we create a calculated parameter to understand the weight of each section type. To do this, let's go back and select Edit for Fields. Again, in the Schedule Properties dialog box, you'll note here that we can add a calculated parameter. Now, there are many ways to calculate the approximate steel tonnage used in the project. In this example, I'm going to go ahead and utilize the volume of material used. So I'll bring across volume, and now I can create my calculated parameter. So I'll click Add Calculated Parameter. For the name, this is going to be weight, and this is going to be in tons. And then we can put in a formulae. Now you notice that we have type here, and currently I'm just going to use number. We have to be mindful here that we'll need to remove the formatting of things like volume. For example here, what I'm going to do is I'm going to take the volume, so let's pick volume here, and we want to multiply that by 490. The reason why we're doing this is there's approximately 490 pounds to a cubic foot. That's the volume of steel, approximately. If I just go ahead and select OK to this, you'll notice that we get inconsistent units because we have a unit here that is a volume calculation. So what we can do here is we can just divide out those units. So if I divide by 1 cubic foot in here, of course, that's absolutely fine now. If I go back and edit the parameter, you can now see that we can continue to work out our calculation. Now, what we want to do to calculate a tonne, there's 2,000 pounds to 1 tonne. So what we need to do here now is divide the whole value by 2,000. Let's go ahead and click OK. Now, if we select OK again, you'll note that we have the volume and the weight, but everything is blank at the minute. The reason for that is we've got a rolled up schedule. So of course we have to tell the framing schedule that we want to calculate totals. To do this, let's select the Edit by Formatting. So you'll notice on the Formatting tab here, if I select Volume, I can change the calculation from No Calculation to Calculate Totals. I'll do the same for my weight, Calculate Totals. You can now see we have our volumes and our weights. Now, once again, the volumes were only there to help me calculate the weight, and it might be quite nice to understand the total tonnage for all of my structural framing. So, if we go back to the Properties palette and again select Formatting, I can select Volume, and once again, I can select Hidden Field. And if I then return to Sorting and Grouping, finally, I could ask the schedule to display the grand totals. And you can now see we have a grand total, so we've got just under 21 tonnes. After completing this lesson, you'll be able to understand tags, create a structural framing tag family, and add tags to a structural plan. The objective domains covered are 3.1b, create and modify annotation families for documentation. A tag is an annotation element that reports on specific information that resides within structured elements. For example, a beam tag could report on an elevation, display the quantity of shear studs, display the element weight, or in fact the type mark. The image at the bottom of the screen is showing the beam designation as well as the span to depth ratio. This is placed in one go with the beam annotation. Go ahead and open up the model 030, creating and modifying annotation families for documentation. The model opens up in the 05 fifth floor plan. You can see here that we have a roof framing plan, and here we have bracing. Our first task is to tag the bracing. To do this, select the Annotate ribbon and select Tag by Category. On the Options bar, we can control the placement of the tag, whether it's horizontal or vertical, and also the type of tag we're placing. So here we can access our loaded tags. In the Loaded Tags and Symbols dialog box, let's expand our dialog, and we'll scroll down to find Structural Framing. We can now designate which type of tag we would like to use for our framing. So here I'm going to specify Structural Framing Tag Standard. We can then click OK, and you'll now notice as we move over the braced elements, we have our tag displayed. Another option we have here is to remove the leader. I can then go ahead and place my tags. Now, of course, I could continue to tag the rest of the framing plane, but what I'd like to do here is utilize the type mark of the frame rather than the full designation. To do this, I'll need to edit the tag. Select one of the tags that you've just placed, and on the context ribbon, go ahead and select Edit Family. The tag then opens up in the Family Editor. You can see here that I have a label shown on screen, so I'm going to go ahead and select this label, and again, on the context ribbon, I can edit the label. Currently, we're showing the full type name. So I'm going to select this and then remove the parameter from the label. What I want to use is the type mark. So of course we can select type mark here and we can add the parameter to the label. You'll notice in the label parameters area we can add multiple labels into this, and we can also have suffixes, prefixes, breaks, spaces and so on. Here I'm going to change the sample value, and I'm just going to call this one W1. Go ahead and select OK. We can now see a preview of our tag. If my intention in the project is to replace all the framing tags with the type mark designation, I can leave the family name the same and simply load into project and close, and that will replace all of the tags I've automatically placed. Let's go ahead and do that. So we'll select load into project and close. I don't want to save this, but in the project I want to overwrite the existing version. You'll now notice that the bracing now shows the type mark designation as opposed to the full call up. And of course here I can use the inbuilt move tool to reposition these tags to a better location. Next, I'm going to create a new tag to report on the span to depth ratio of our structural framing. Before we go ahead and create that tag, let's view that property in the Properties palette. Go ahead and select a beam. And in the Properties palette, you'll notice here under Structural Analysis, we have span to depth ratio, and it's holding a value. We want to create a tag that's going to report on this value for all of our framing members. To start, let's create a new family. Click File, then select New and Family. In the Select Family Templates dialog box, open the Annotations folder and then select Generic Tag. Now, a generic tag is generic in its nature, and before we can use this for a particular structural category, we must set the family categories and parameters. This red text here is reminding us to do this. So we'll go ahead and delete that text. On the Modify ribbon, let's go ahead and select Family Category and Parameters. Notice that the default category is Generic Model Tags. We'll go ahead and select Structural Framing Tags. A very important property under Family Parameters is Rotate with Component. Now, when we place this span to depth ratio down, we want it to be aligned to the beam. So, of course, yes, we do want that to rotate with a component. Go ahead and select OK. We're now ready to create our label. Select the Create ribbon and then select Label. Here is the default label size. And then we can pick where we want the label to be created. I'm going to select roughly the center of my reference planes. I'm then presented with the Edit Label dialog box. Now, our span to depth ratio will not be displayed in this particular dialog because it's a shared parameter. So we can go ahead and add that parameter. Let's click Select. And now we'll change our group to Structural Framing. And here we have our span to depth ratio. We can then go ahead and add that across into our label parameters. Now we'll give this a realistic sample value. So I think here we'll type in something like 12. And then we want to designate a prefix to this. So I'm going to type in here S:(D), and then I'm going to put a space in. So span to depth ratio, and then it's going to give us the span to depth ratio with a space. Let's go ahead and select OK. And there's our new tag created. Of course, we'll need to save this. So on the Quick Access toolbar, select Save. Save it into your current folder, and we'll call this span to depth ratio. Go ahead and select Save. We now want to load this into our project and close, so we can click Load into Project and Close. And of course now when we hover over structural framing, you can see that Revit is now displaying our span to depth ratio. We're not going to add that using the tag, we're going to use a beam annotation to add this as well as a tag. A more efficient way of placing tags on the plan is to use beam annotations. Beam annotations are capable of producing not only tags, but also spot elevations as well. We can combine these in pretty much any combination we want. We can tag the end of the beams, the start of the beams, as well as the mid positions on the beams. And as I've said, we can use spot levels on either side of the beam. To configure this, on the Annotate ribbon, let's select Beam Annotations. In the Beam Annotations dialog box, you'll note here that all beams in the current plan view are going to be placed with a beam annotation. We also have two tabs here. We have level beams in plan, and we also have sloped beams in plan. Our roof plan contains both level and sloped members, so we'll set the same settings for both of these tabs. Before we go ahead and set this area up, you'll also notice here we have placement settings. This configures the distance of the tag or the level from the end of the beam, also the vertical distance from the edge of the beam. You'll notice the default value is 3/8, but of course I could change that if I wanted to. Let's go ahead and select OK to placement settings. So in the first tab, level beams in plan, you'll notice at the minute that we're showing structural tags at the start and the end of the beam, as well as a tag in the center of the beam. Let's set the tag at the end of this beam. So here, currently, we're showing the start forces on the beam. Note I could show a spot elevation, but in this case, I want to select none. I'll do the same for the right-hand side of the beam. And we just want to ensure that this tag in the center of the beam is in fact our standard framing tag. You may remember that the standard framing tag is just going to report on the type mark. At the bottom of the beam, we're going to place our new span to depth ratio. So let's select structural framing tag, and you'll note the type is span to depth ratio. Of course, we could select a new type if we wanted to. Let's repeat these settings for sloped beams in plan. So we'll make sure we set the start and end tags to none. Double check that this tag is reporting our standard type mark. And here again, we'll add in a structural framing tag of our span to depth ratio. Go ahead and select OK. And you'll now note that the beam designation tag and also the span to depth ratio and is now tagged on all of our roofing plan. Much more efficient way of placing tags.